What's going on? I'm looking at a story that genuinely rewrites everything we thought we understood about the 2026 Belgian Grand Prix. And if you're a fan of Formula One, you're going to want to buckle up because the details here are almost too wild to believe. Toto Wolff didn't just give a coy diplomatic answer during a routine press conference. He dropped an absolute truth grenade that nobody saw coming. Every single Mercedes-powered car on that Spa grid, all 8 of them, rolled off the line with a crippling software problem baked right into the engine's brain. This wasn't a minor calibration hiccup, it wasn't a questionable setup choice, and it certainly wasn't just bad luck for George Russell. We're talking about a full-scale digital epidemic that strangled the top-end power from every machine running that 3-pointed star power unit right when the lights went out. And here's where it gets genuinely uncomfortable. That split-second electronic failure didn't just cost a few tenths per lap, it turned the Kemmel Straight into a danger zone, contributed to one of the most violent opening lap crashes we've seen in years, and left multiple world-class drivers fighting an invisible enemy they had zero control over. I'm going to walk you through exactly how this catastrophe unfolded, the deeply buried technical monster that caused it, why this could have spiraled into something far worse, and the one lingering question Toto Wolff still hasn't fully answered. But before we unpack all of that, you need to see the sequence that's been haunting Mercedes engineers ever since. Imagine being strapped into a car that has been tuned for months to deliver seamless hybrid boost. You plant the throttle exiting La Source, you're expecting that violent shove of electric torque pushing you toward Eau Rouge, and instead, you get nothing. The system hit an energy harvesting ceiling before the race had even started breathing. From turn 1 all the way to turn 5 on the very first lap, every Mercedes engine machine was effectively running a power deficit that turned the most fearsome straight in motorsport into a sitting duck parade. Now, I've been following this sport long enough to recognize a cover-up when I see one, and the immediate aftermath of the Belgian Grand Prix felt strange from the moment the checkered flag fell, but none of us could quite put our finger on why. You had the usual post-race soundbites about tire degradation and aero efficiency, but there was this thick layer of awkwardness hanging over every Mercedes-powered driver interview. Nobody wanted to say what was really going on. George Russell's race ended in carbon fiber shower before most fans had even found their seats, his car spearing into the barriers after what looked like a bizarre loss of momentum on the Kemmel Straight. The official line was a racing incident, but even the replay looked odd. It was as if the car just ran out of puff at the worst possible moment. Then you had the other Mercedes power drivers, and I'm talking about names that normally slice through the field like hot knives through butter, all suddenly reporting the same eerie sensation, a lack of punch, a missing top-end surge, a feeling that the power unit had fallen asleep at precisely the wrong time. At first, the skeptics among us wondered if it was the new 2026 aero regulations creating a wake sensitivity that disproportionately punished certain engine modes. Others whispered about fuel flow sensors playing up in the colder-than-expected Ardennes air. But I'm telling you, the reality is simultaneously simpler and far more alarming. According to sources and the confirmation that later came directly from Toto Wolff himself, every single car utilizing the Mercedes high-performance powertrains package suffered from an identical software glitch that triggered an emergency energy deployment clampdown the moment they crossed the start line. This wasn't a mechanical failure, it was a logic error, a phantom line of code that convinced the engine management system it had already harvested enough energy to recharge the battery, so it slammed the door shut on further deployment. Imagine your smartphone deciding it's at 100% battery when it's really at 15, and then shutting off all high-performance functions to save power. That's effectively what happened inside 8 of the most sophisticated racing machines ever built, all at once, with absolutely no warning. The sheer statistical improbability of this hitting all Mercedes customer teams simultaneously is what initially made me believe it had to be a hardware defect, maybe a bad batch of sensors. But no, Toto Wolff explicitly confirmed it was a software glitch that was sitting dormant in the engine control unit, waiting for a very specific set of conditions that unfortunately aligned at Spa. And that's where the sarcastic side of my brain kicks in, because we're talking about an organization that spends hundreds of millions of dollars perfecting combustion chamber geometry and battery thermal management. Yet a few lines of code turned the whole project into a glorified vacuum cleaner for an entire opening lap. It's like building a skyscraper and then realizing you install the elevator buttons upside down. I'm not mocking the engineers, I genuinely sympathize with the nightmare they must have lived through, but you have to appreciate the cosmic irony that a sport drowning in data and simulation still gets blindsided by the digital equivalent of a typo. Now, let's get into the nuts and bolts of what actually went wrong, because the technical explanation is both fascinating and terrifying for anyone who cares about racing integrity. Modern Formula One power units are not just internal combustion engines bolted to turbochargers. They are intensely complicated hybrid systems that juggle multiple energy flows simultaneously, and the software that manages those flows is arguably more critical than any physical component. In 2026, with the new regulations pushing even greater reliance on electrical energy recovery and deployment, the engine control unit has to make thousands of calculations per second, deciding precisely when to harvest kinetic energy from braking, when to deploy it for acceleration, and how to balance thermal loads across both the MGU-K and the new, more powerful MGU-H derivatives. At Spa-Francorchamps, the energy management strategy is particularly delicate because the circuit is so long and the straights are so brutally demanding. The system is designed to hit certain harvest limits early in the lap, to replenish the battery after the massive discharge needed for the start. According to reports, the software fault caused the control unit to prematurely believe that the harvest limit had been reached the moment the cars exited turn 1. The moment it made that incorrect determination, it effectively neutered the deployment for the subsequent sequence, thinking it was protecting the battery and electrical systems from overload. The result was that for the critical run from La Source up through Eau Rouge, along the Kemmel Straight and down to Les Combes, the cars were operating with a significant deficit in top-end power and boost pressure. On a track where terminal velocity can define whether you complete a clean overtake or end up in a dangerous situation with cars jockeying side by side at over 300 kilometers per hour, the absence of that electric shove was catastrophic. I've spoken to people who understand these hybrid mappings far better than I ever will, and they all describe this kind of failure as a silent killer. The driver feels the throttle response go numb, the shift lights flicker erratically, and the expected surge of torque simply evaporates. In the chaos of a race start, with tire smoke and braking zones and rival cars swarming all around, diagnosing that numbness isn't just difficult, it's practically impossible until you're already in trouble. What makes this particular failure so haunting is that it wasn't a gradual fade, it was a binary switch that flipped at the worst possible nanosecond. One moment the car was ready to unleash its full hybrid fury. The next moment, the software had convinced itself the battery was full and went into a protective limp mode that the drivers couldn't override. And if you think the fix was as simple as rebooting the system, I've got a beautiful bridge in Brooklyn to sell you. Mercedes had to fly engineers back to the factory, tear through millions of lines of code, replicate the very specific race start conditions on a dyno rig, isolate the rogue logic, and then deploy what sources describe as a series of critical code modifications. That's like trying to find a single misspelled word in a 1,000-page novel while the printing press is still running at full speed. George Russell's accident now takes on an entirely different complexion when you stack it against this revelation. And I have to say, watching that footage back with the context of a power deficit makes me feel a little queasy. He was positioned on the outside line going into the Kemmel Straight, a place where you absolutely need that electric deployment to punch through the aerodynamic drag and maintain momentum. Instead, the car hesitated. It's almost imperceptible unless you're looking for it, but you can see that little stutter where the acceleration curve should have been climbing and just didn't. In a tight pack of cars, all jockeying for position, that hesitation created a dangerous speed differential that turned his defensive line into a vulnerability. The car behind, which presumably wasn't suffering from the same issue if it was running a different power unit, closed the gap faster than anyone anticipated, and the resulting contact sent Russell spearing into the barriers with forces that thankfully didn't result in any serious injury. But here's the kicker that keeps me up at night.
Was the crash entirely inevitable because of the software fault, or was there a split-second decision Russell could have made differently had he known his deployment was crippled? That's the cruelest part of this whole saga. The driver has no cockpit warning that says your energy deployment limit has been artificially triggered. He feels the sluggishness and reacts on instinct, trying to compensate with steering input and throttle modulation that was never supposed to be necessary. It's like asking a sprinter to run a 100-meter dash on a partially frozen leg muscle and expecting them not to stumble. Russell, being the professional he is, didn't throw his team under the bus in the immediate aftermath, and I respect that. But you can bet the internal debriefs at Brackley were absolutely brutal. Other Mercedes-powered drivers, whose names I've been told were equally furious behind closed doors, have since described their opening laps as a terrifying guessing game, where they were essentially driving detuned cars in the most high-speed section of any circuit on the calendar. Some managed to survive through sheer luck and positioning, while others dropped like stones through the field before the software eventually corrected itself after a few laps. The fact that the issue sorted itself out mid-race is in many ways even more infuriating because it confirms the hardware was perfectly capable of delivering the full beans. It just wasn't allowed to when it mattered most. I have to give a sideways glance at the FIA scrutineering process here, because if a single supplier can inadvertently kneecap a quarter of the grid through a software oversight, what does that say about the robustness of the verification protocols for these incredibly complex systems? It's a conversation that nobody in the paddock seems eager to have, but it's now unavoidable. The investigation that followed reads like something out of an industrial espionage novel, except instead of stolen blueprints, the villain was a ghost in the machine. Mercedes, to their credit, didn't try to bury the story once the scale of the problem became clear.
Undeniable, but the timeline of their disclosure raises some interesting questions. According to sources, the Brixworth high-performance powertrains team began noticing anomalous telemetry within minutes of the race start, long before any driver had radioed in with complaints. The data streams were showing consistent and inexplicable truncations of energy deployment across all customer teams, a pattern that could not be explained by weather, driving style, or competitive factors. When you see 8 cars all reporting the same electronic signature of a harvesting limit being tripped at the identical corner on the opening lap, you don't need to be a software architect to smell a systemic fault. The decision was made to silently begin a deep forensic investigation even as the race continued, with engineers at the circuit working through the night alongside their counterparts back in the UK who were fed real-time data. What they uncovered was apparently a timing error in the state of charge estimation algorithm that had never previously manifested because the specific combination of battery temperature, ambient conditions, and the extremely rapid energy discharge required for a standing start at high altitude hadn't been encountered during preseason testing. The Spa circuit sits nestled in the Ardennes forest, with elevation changes and air density factors that interact with turbochargers and hybrid systems in ways that simulator models sometimes struggle to perfectly replicate. The software fix, as confirmed by Toto Wolff ahead of the Hungarian Grand Prix, required not just a patch but a fundamental rewrite of certain energy management tolerance checks to ensure the state of charge logic could never again be fooled by transient spikes. The engineers reportedly worked around the clock, running the updated code through simulated race starts and full Grand Prix distance dyno cycles until they were satisfied the glitch was eradicated. I find it genuinely impressive that they managed to identify, fix, validate, and deploy the solution in the gap between Belgium and Hungary, which is not a huge amount of time in the world of power unit development, where changes normally take months to approve. The fact they pulled it off suggests this was a very specific and contained logic flaw, rather than a widespread architectural weakness, which is comforting in one sense, but also a little worrying because it means other similarly hidden flaws could theoretically still be lurking in the mapping. And yet, through all the technical transparency, there's a nuance that Toto Wolff has been careful to dance around. Did any of the Mercedes-powered teams know about the potential risk ahead of the weekend? I'm not suggesting a conspiracy, but in a sport as paranoid as F1, the timing of the discovery and the silence during the race does make you wonder whether there was an internal hope that the issue would clear itself quickly and go unnoticed. That's not an accusation, just a natural question that any journalist or fan would ask when a problem of this magnitude affects 8 cars and nobody says a word until it's confirmed at the next race.
To me, that's the unanswered hook that still hangs in the air, and I suspect we'll hear more whispered details as the season progresses. Looking forward, the implications of this software scare stretch far beyond a single chaotic afternoon in the Belgian forest, because we're now living in the 2026 era of Formula One where electronic and hybrid performance has become the dominant battlefield. The days when a simple engine misfire could be solved with a wrench and a fresh spark plug are ancient history. Now, the race is won and lost in the mind-bending complexity of code that governs how many kilojoules of energy can be deployed per second and how efficiently that energy is harvested. The Mercedes glitch serves as a stark warning to every other power unit manufacturer, Ferrari, Red Bull powertrains, Audi, Honda, that a single overlooked conditional statement can turn a potential podium contender into a mobile chicane. I've been saying for a while that software reliability is the invisible frontier of modern F1, and this incident hands me a bullhorn to amplify that argument. The teams invest incredible resources into the mechanical durability of pistons, crankshafts, and batteries, but the line between flawless performance and catastrophic failure is now just a character string in an embedded controller. If I were a team principal at McLaren or Williams right now, I'd be knocking on Mercedes' door demanding not just a software fix, but a full audit of every energy management module, because the consequences of a repeat failure at a track like Monza or Las Vegas don't bear thinking about. The fact that the issue is reportedly fully resolved for the Hungarian Grand Prix is reassuring, but the psychological scar will linger. Every driver in a Mercedes-powered car will now be subconsciously waiting for that odd throttle numbness on the opening lap, and that kind of doubt can influence split-second decisions in a dangerous way. From a championship perspective, the lost points at Spa could prove decisive if the title battle remains tight through to Abu Dhabi, and I can already imagine the fiery debates among fans about whether the points lost due to a supplier software fault should be somehow addressed by the sporting regulations. The current rules don't allow for any compensation in such scenarios, which feels brutally unfair, but changing that would open up Pandora's box of lobbying and appeals every time a car suffered a technical glitch. My personal opinion, which I'll offer without pretending to be neutral because I'm here to give you genuine human analysis, is that the FIA needs to mandate far more rigorous software stress testing that specifically includes race start edge cases with cold systems and maximum electrical load. If the governing body can demand crash tests and load tests for physical components, why not for the digital ones that are now equally critical? I'm not holding my breath for a quick regulatory overhaul, but if this glitch had caused a more serious accident, and it came terrifyingly close, we'd be having a very different conversation right now. The sheer luck that nobody was injured beyond the usual race weekend bumps and bruises is something we should all be grateful for, and that gratitude should translate to proactive change. So where does this leave us heading into the Hungarian Grand Prix and the second half of what is already becoming one of the most fascinating Formula One seasons in recent memory? On the surface, Mercedes appears determined to close the book on the entire controversy. The team has identified the issue, rolled out a software fix across every Mercedes-powered car, and team principal Toto Wolff has publicly stated that the problem is fully resolved. From Mercedes' perspective, the message is clear. The crisis is over, lessons have been learned, and everyone should move on. Personally, I'm cautiously optimistic. Mercedes has one of the most experienced engineering departments in motorsport, and when they say they found the root cause of a problem, there's usually a great deal of evidence behind that conclusion. But Formula One has taught us over the years that absolute certainty is a dangerous thing. Anyone who has followed this sport long enough knows that statements like, "it's completely fixed," often translate to something slightly different behind closed doors. We're confident we fixed it, but we'll only know for sure once the cars complete an entire race weekend under competitive conditions. Unlike Spa-Francorchamps, where the issue first became impossible to ignore, the Hungaroring presents an entirely different engineering challenge. Spa is all about long straights, maximum deployment, heavy braking zones, and sustained periods at full throttle. Those characteristics place enormous stress on every part of a hybrid power unit, particularly the complex electronic systems responsible for managing energy deployment. Hungary, by contrast, is often described as Monaco without the walls. The circuit is tight, technical, and incredibly demanding from a mechanical setup perspective rather than outright power. Drivers spend far more time negotiating medium and low-speed corners than accelerating down endless straights. Because of that, the power unit isn't subjected to exactly the same kind of prolonged high-load scenarios that exposed the software anomaly in Belgium. If the software update performs exactly as intended, Hungary could provide the perfect opportunity for the team to quietly rebuild confidence without facing the same extreme stress test that Spa presented. A clean opening lap, consistent power delivery throughout the race, and no unexpected telemetry anomalies would go a long way towards reassuring both Mercedes engineers and their customer teams that the nightmare really is behind them. Even if every Mercedes-powered car completes the Hungarian Grand Prix without the slightest hint of trouble, there will still be lingering questions surrounding how this situation unfolded in the first place. One of the biggest mysteries isn't simply that a software bug existed. Complex systems occasionally produce unexpected problems. The more intriguing question is timing. Formula One is a sport built on information. Every team studies its competitors relentlessly, searching for the smallest clue that could reveal either a weakness or an opportunity. That means rival engineers won't simply accept Mercedes' reassurance at face value. They'll be watching every Mercedes-powered car throughout practice, qualifying, and race itself, carefully examining speed traces, sector times, onboard footage, and any available telemetry for signs that the issue could resurface.